Welcome to section 15.2, Rational Exponents. So today we're going to cover when an exponent is in the fraction form. So we already know that we can convert a whole number into a fraction by putting one underneath it. Now here is when you actually have an exponent that's already a fraction. Now I'm going to talk about how to go from rational exponent to radical form and vice versa. Now on the left side, we have x to the power of a over b. So this is the rational exponent form, or exponential form. Now on the right side is the radical form. The radical is what you see here that's on the x. Now at the top is we have the b root, because the index is b, the b root of x to the a power. Now notice how we have the a inside the radical. Now let's compare it to the second form, its equivalence form, where it's now the b root of x being raised by the a power. So in the second form, the a is now outside the radical, but is also outside the parenthesis. Now, if you are going to write the a outside, meaning the a exponent outside the radical, you must include the parenthesis so that you can state that the b root of x is being raised by a. Now, even though in the first form we don't have the parenthesis, it's because the a, it always applies to the x. Now, if you have multiple parts that involves with the a exponent, then it is best to include parentheses. And you will see what I mean with the following examples. So, I recommend that you be familiar with transition between rational exponent form to radical form with either forms, with these two forms here, and then vice versa. Now, if I were to ask you to convert from rational exponent form to radical form, either of these forms are acceptable if, say, it was on the test. So, again, if you were to convert from rational exponent to radical form, again, either forms that you give me are acceptable. Let's take a look at the first example. Here we have the square root of m to the third power. And just like how I mentioned, the index here is an invisible 2. So if you don't see a visible number, that means that the index is 2. So that's why we call it the square root. So if you were to rewrite it in rational exponent form, meaning this form on the left, so first I'm going to write my m, then what's my a, the exponent inside, that will be my numerator. What's my b, which is the index on the radical, that's my denominator. So my answer is going to be m to the power of 3 over 2. So that would be my rational exponent form, and that would be my final answer. So it's going to be m to the power of 3 over 2. So that's all you have to do. Just make sure you follow the format so that you don't mix up your exponents. In this example, we have the cube root, or the third root, of 6x to the fourth power. So again, we call it the cube root or the third root because of the index 3. Now notice how on the 6x we have parentheses is because the 4 exponent, it applies to the 6 and the x. In addition, that we have multiple parts inside the parentheses, meaning that we have a number and the variable. So if it's 6x and the 4 applies to both, that means you have to include with the parentheses. So if you were asked to rewrite it in rational exponent form, so we're going to write the inside 6x, we're going to put in parentheses because we have multiple parts where the exponent applies to the 6 and the x. So the exponent that's inside the radical, that's going to be my a, so it's going to be 4 on the top. Then my denominator is the index, which is the 3, that's going to be the denominator. So my answer is, in rational exponent form, 6x to the power of 4 over 3. And that's going to be our final answer. to review, if you see that you have parentheses at the very beginning, make sure to include it in your answer, because as I stated before, the 4, it applies to the 6 and the x, so we're going to group it together. And if you were to write it in rational exponent form, you still have the parentheses, it's just now the exponent is 4 over 3, meaning that it applies to the 6 and the x together. In this example, we are given the rational exponent form. Now we are to convert it into radical form. So if you were to ask to convert in radical form, again, be familiar with the two forms, which I'm going to do for both. So I'm going to have m. Now the numerator of the fraction, it will be with the n, so n to the 7th power. Now the radical, the index of the radical is going to be the denominator from the fraction, which is 4 right here. So that's the first form, the 4th root of n to the 7th power. Now the other form that you could write is n with the 4th root, and then you're going to put this in parentheses, being raised by the numerator, which is 7. So that's the second form that you could write. So the first form is where the 7 is inside the radical on the n. And then the second form is where we have the 7 outside the 4th root of n. Again, either form is acceptable. I'm just doing for both in case one decided to do the first while the other decided to do the second. In this example, we have 3a to the power of 5 over 2. Now in this example, we have the number 3 and the 8 together in parentheses where the 5 over 2 applies to both. So that means that we should include our parentheses in our final answer for radical form. So let's rewrite it. I'm going to use the first form. Now we're going to have 3a in parentheses. The numerator will be the exponent on the 3a, while the 2, the denominator, will be the index of the radical, meaning square root. Now, you can leave it like that because, again, a square root doesn't really require the visible 2, but if you do write it, that's okay. Points won't be taken off. It's just you're just stating that this is the second root or the square root. Again, this is the same as if you were to write it as 3a to the power of 5 inside the square root. Again, the one on the left is with the visible 2, the one on the right is the invisible 2. Now the second form would be the square root of 3a, just like that. And again, you can write the visible 2, but now we have parentheses where the 5 is outside. And again, just like I said before, you can write with the visible 2 or you don't have to if you're working with square roots. Just like that, parentheses with the 5 outside. Again, the one on the left is the visible 2, the one on the right is the invisible 2. When we're working with square roots, the name already implies you're working with the second root. But again, be familiar with the two forms where you see here parentheses on the 3a with the 5th exponent or the power of 5, whereas over here, same thing as usual. Now we have parentheses on the whole thing with the 3 and the 8 inside the radical and the power of 5 outside. So again, be familiar with the two form, but to review, since we have two parts, 3a, you see how we have parentheses on it. Make sure you include parentheses on the 3a when you put in the exponent inside the radical. So again, this is our final answer. I can accept this form where the power of 5 is inside the radical or where it's outside the radical. Either form works. But be very careful. If you have parentheses going from rational exponent to radical, then make sure to include parentheses inside the radical if you put in the exponent inside the radical.